to Taxonomy Online Mathematics. I am Fred Gakbo. We are still continuing with a topic on surd. In the previous videos, we talked about the concept, the similar surd addition, the rules of multiplication and division. So now we want to take rationalization. Now, if you are asked to rationalize a surd, it means that it is just a method you are using to simplify a given surd that have a surd as either the denominator or both the numerator and denominator. What I mean is that if I have a question 5 on root 5, this is a surd that needs to be rationalized, whereby we are trying to make it in a way that the denominator will be a rational number rather than what? Irrational numbers. So we multiply by the denominator. So we rationalize so that we can get only the denominator. So the only way I can get 5 here is using 5 to multiply, using root 5 to multiply root 5. In that case, I can get 5. So if I'm asked to rationalize 5 over root 5, what I will do is that 5 on root 5, I use this as our denominator to multiply both this and this. We multiply the top because whatever I do to the numerator, I have to do the same to the denominator so that it will not affect the equation. Because root 5 over root 5 is 1. 1 times my equation remain the same. So in this case, I'm going to have 5 root 5 over root 5 times root 5 is only what? 5. And we know that this 5 is rational, this is rational. So our final answer is going to be root what? 5. So in rationalization, all we are doing is that we try to make sure the denominator is only a rational number. So if I have another question, if I have 1 over root 13, so to rationalize, the denominator is also we've said. So we multiply the top and the down with the same 13. So root 13 multiplying 1 will remain root 13. 13 as a root times 13 as a root will give us 13 as our final answer. So this is what you get, root 13 over 13. So this is perfectly simplified, but this is not simplified because the denominator consists of surd. So this can also be written as, there is a 1 here, so 1 over 13 root 13. So this will be the simplified version of what we have. What if I'm asked to simplify this? We can see that the denominator consists of rational and irrational. So we are saying that the denominator should not consist of what? Irrational. So how do we eliminate the rational out here? Yes, we can use the two numbers, both rational and irrational. But it will be easier to use only the irrational because the 6 is already rational. I am trying to make the root 2 to become rational as the 6. So I will leave the 6 and take only the root 2. So that becomes 5. So I'll multiply the top and down by the root 2. Which I can still use 6 root 2 in multiplying. It only increase the numerator and increase my coefficient. But I will still get the same answer. But this is the simplest form. So 5 times this will give us 5 root 2. Then root 2 times root 2 will give us 2. And that 2 is multiplying 6. So 6 times what? 2. So right away, I have 5 root 2 over 12. So since there is no common factor for 5 and 12, we leave it like this, or we rewrite it as 5 on 12 root of what? 2 as our final answer. Alright, so this is what we do under rationalization. This is where the denominator is only a singular set. But if it become a mix or compound set, then it means that we have to employ the properties of conjugate pair. We talk about conjugate pair in some of our previous videos. So if you have that, then you can also use a conjugate to multiply to change the denominator. Alright, so for example, if you have a fraction like this to be simplified, we can see that our denominator is no more a singular set, but rather a mixed set, whereby we have rational and irrational. So we are going to use the conjugate pair. You know, conjugate pair is just getting a pair to what we are giving, multiplying them to get rational. So I'll be having 2. This is going to be 2 times 3 minus root 3. These are the same because if you cancel, you have to get 1. This is the conjugate pair of the denominator. We explained that in our previous video. So now we are going to multiply the numerators together. Don't forget, this is no more a singular term. So the 2 is going to multiply both the 3 and the minus root 3. This will multiply this. So let's write them this way. Then we have 3 plus root 3. So now when you use 2 to multiply this, we have 6. Now from the previous video, when you get a conjugate pair, and this is also a difference of 2 squared, because this is going to be the first number squared, the last number squared. That's what will give us this as a difference of 2 squared. If I have 3 squared minus the root of 3 squared, this is what I'll get as an expanded form of it. So it means that I only multiply this by this to get 9, then multiply the root by the root, and we know root 3 times root 3 will actually give us what? Only 3. So from there, since we cannot subtract this because this is not having any root, so we maintain 6 minus 2 root 3 all over what? 6. This is what we get. We cannot use this 6 to cancel this. We cannot use these 2 to cancel this because they are 2 separate terms. But we can separate them to be 6 divided by the denominator minus 2 root 3 divided by the denominator. We can separate them, but we cannot use this 6 to cancel this, nor these 2. Then I'll be having 1 minus this will cancel this, will give us root 3 over 3. So I can present my answer in this form as a final answer. At this place, I can't cancel, so I leave my answer at this place. Alright, thank you. This is your online teacher Gakpo Fred on Taxonomy Online Mathematics. Thank you.